Hello friends, this is Durga again from ITversity. As part of this video, I'll be covering joining disparate datasets together using Spark, using Pyspark especially. And already I have covered how to implement using a plain a simple Python script. In this video, I will try to cover how we can do it in more elegant manner by using uh, either HighContext or SQL Context. If you are familiar with SQL, this will be much more helpful for you, and it will be much more quicker to write the programs at the time of the certification. That being said, I'm going into my VM. To launch the VM, you don't need to run any special commands. You can run as we are doing earlier. You have to give the absolute path of the Pyspark for 1.2.1. This is the location from my home directory, and then I am using local mode rather than yarn mode, so that it will launch faster. But you can use the yarn mode also if you are interested in, just by ignoring minus master local, or you can pass yarn as part of minus master parameter. Now you are in Pyspark console, and first thing you need to do is you have to import HighContext from pyspark.sql like this, and then you have to create a variable for HighContext by passing Spark context variable, which is a C in this case, and hit enter. Now you will be able to run queries directly on the Hive tables. Before running queries on the Hive tables, you need to make sure that you have the tables in Hive. For that, you can launch Hive. And if you are following my playlist, we started with Scoop, and we have done import all tables, Scoop import all tables by using one minute, let me show you. So if you follow my scripts, we have ran import all tables couple of times. The first import all tables will store data in retail store under this location, user hive warehouse retail underscore stage.db or user hive warehouse, and all the tables will be created over there. If you use create hive table, actually we have ran couple of import all tables, and the last one is this one, which will actually use compression codec of Snappy, and then it will actually create the Hive tables in the default database. Because import all tables always creates the tables only in default database, you cannot actually give custom database, especially if you have create Hive table or doing Hive import for the data. For that reason, we will be using the default database. If you follow my videos, you will already have the tables. You can validate by launching Hive, which will launch you into the default database, and then run the show tables. You can see that you have the orders table and order items table here. You can actually describe orders to get the column names. We have order ID, order date, order customer ID, and order status. And also you can describe order items. You have all the tables. If you are using VM and if you don't find the tables, go back to my Scoop demo file and run the Scoop import all tables. If your database is in inconsistent state, make sure that you actually delete all the files which is under the default Hive warehouse location, which will look like this: user Hive warehouse. For some reason, if it is not working, what you have to do is you better drop all the tables from Hive and then run the Scoop import all tables command. So you make sure that you drop all the tables just for the safer side, and delete all the directories also if there are any inconsistent files or directories in the Hive warehouse. And then you can import the tables using this command. It will create all the tables in our Hive database with the structures. Okay, then you can once you confirm that you have all the tables, now in this case I am confirming, I can actually run the orders and order item, count on orders and order items, or I can actually do select star from orders limit 10 to validate that I can see the I have the data, and order items limit 10 also. If you want to make sure that you have all the data, you can run the count on both the tables and it should match with your MySQL database. Just double checking everything is in place. Once you confirm, and also you can run the queries from here also. For example, you can say SQL Context.sql select count of 1 from orders. Because it's in default database, you need not specify the database name as a prefix, and then hit enter. Actually we have to assign it to a variable cnt equal to, and then you can say cnt or cnt print of cnt and hit enter. What happened? For I in cnt.collect, because it is creating RDD, it is not printing properly. You can say print of I, and you can see there are 68,883 orders. Similarly, you can also do order items, and then you can, it will return 172,198 records. So we have the data, actual valid data here. Now you are able to access orders and order items using SQL Context. Hence we can actually join directly, join RDD. I'm just giving the name SQL Context dot SQL, and then we have to get, I will be giving alias O for orders and OI for order items. Orders have order date column, so I am using order date here because that is the key for our aggregated data after the joining. So I am referring order date with O here, and then sum of OI dot order item subtotal, and then I have to get count of distinct order ID, O dot order ID. I can get either from order items table or orders table, it doesn't matter. In this case I am getting from the orders table. Now I have given all the 3 fields which are required. Now I am giving some clause orders O join order items OI on O dot order ID equal to OI dot order item order ID. Now the join is done. I am giving a space slash so that I can continue the command in the next line. You should not hit spaces here because the Python, if you give spaces, Python thinks that it's a scope for the previous command, which is invalid syntax. So you should not give any spaces when you give line break and continue the command in the next line in Python. For that reason, I am not hitting any spaces, and then I have to group by O dot order date because I want the count and sum of revenue for each order date, and also I want to sort to make sure that I am getting results properly for the last date, so that we can actually cross check whether the data is correct, whether the results are correct or not. It is better to give order by and follow the same in all the wherever you want to validate, and then if it is, it's called sanity check. To make it easy for my sanity check, I am giving this order by. Actual sorting and all will be covered later. And in this case I want to order by order date, and that's it. Hit enter. Now the join RDD have the result set. One command, you got everything. Now you can actually do for I in join RDD dot collect and print of I and hit enter. Now it will process the data, but if you see, it is running very long because it is actually issuing 200 tasks for this query. It's a default for HighContext or SQL Context. If you run any queries, it will try to use 200 tasks to process the data for each and every step, which might not be good. So there is a way to fix that, which we will see in a moment. Once this query is, once this script is done, you got the results, and the data is already in sorted order. And you can see that the last one is 165 and 97,076. If you want to compare with our previous script, which is our plain join with our Python scripts, you can do that also here. So the last one is 165 and 97,076. Okay, and then final join. Paste for I in RDD dot sort by key collect print of I. If you see, this one did not use 200 tasks. It has used far lesser. It has used only 10 tasks in this case. But when you try to run in a HighContext or SQL context, it will try to use 200 by default. Anyway, we will see how we can address that later. But if you see the results, you can see that this is giving 165 and 97,076, which is the revenue for the last day and number of orders for the last day. Similarly, if you try to print on our data set using HighContext, it's 165 and 97,000. You can see that the number of orders are 165 and the revenue is 97,076. So we got the same result whether we run using the join using the query and then aggregate or the Python script. Okay. Now, if as I have mentioned earlier, when you run in the HighContext, typically there will be 200 tasks that will be performed on each and every step. So there, if you closely observe, it has used 200 tasks twice because it will create something called DAG, which stands for acyclic graph, and at each hop it is using 200 tasks. I don't want to confuse with those buzzwords at this time. We will see that in detail in some other video. But if you want to address and use fewer resources to process your data, or more resources if you are trying to deal with a huge set of data, you can use this command called Spark SQL Shuffle Partitions. You have to set it on the SQL context and you can paste it here. And now if you run this query, which is joins the data and aggregates the data, you can see that it uses far fewer resources and the results also results will be returned faster. It's already done. Okay, so that's how you can actually use HighContext. There is another context called SQL Context, which is Spark SQL Context. In the later versions of Spark, they have introduced something called data frames starting from 1.3.0. If you are already familiar with the data frames, you can tend to use the data frame APIs, which is incorrect for the certification. So make sure that you ignore the data frame part of it if you want to use the Spark SQL context and use the legacy Spark SQL context. If you if there are no tables in Hive for to write these complex applications using Python. Okay, let us see how we can actually achieve by using Spark native SQL. For that, you have to import SQL context, not the Hive context. I am copying this one and importing the SQL context from Pyspark, and also there is a class called row. I am importing that also, and I am building SQL context with SQL context. Previously I used SQL context only for Hive context. Now I am calling SQL context constructor and assigning it to a variable called SQL context or object called SQL context. And here it's a little bit more complicated because we have to define the schema on the data. This one is straightforward. We have been doing this all the time. We are reading data from orders table using sc.text file because we are trying to process text data in this case, which are under user cloud scoop import /orders for orders table. And then you have to run the map function to split the data. So now this one will have the array of each and every value. You can validate it, each and every column value in your in your data set. You can validate it by running for I in orders map dot take 5 print of I. You can see that it is returning the array. The square brackets here represents array, and the first item of array is the order ID for each record, and the second item is order date, third item is order ID, and fourth item is order state. It is also a simple map command to split the data into multiple attributes, and now we have to define the schema for this. And the way you define the schema is a two-step process. First, you have to process it as a row using the row class by invoking the row constructor, and then you have to give the names for each and every item in the array like this. So in this case, order ID will be the first item of our result set. So this will be the order ID. As it is of type integer, I am typecasting it into integer. So if you have to do this, you have to follow whatever information you have as part of the examination. Probably they might give the type of each of the fields, and you have to typecast something like this. Order date is string, so I am leaving it as string here. Order customer ID is again integer, which is the third column, and the fourth column is the order status. So this is another map command to process the each record or row and assign name to each of the value for each row. You can run this command, and you can validate by saying for I in orders take 5, sorry, it's order dot print of I, and hit enter. You can see that now the row have the names. It's a key value pair, the key being the column name and the value is the actual value. For each row you can see that. Now using these orders you can create a schema. There is a method called Inference Schema under SQL Context. So you can create the schema like this. It's pretty straightforward, and then you have to register it as a temp table. And now you can use this name as your table name and run SQL Context .sql select count of 1 from orders and get the results. I have to give it to a variable, so let me create a variable for this, cnt equal to, and then for I in, because it's a RDD, I have to do this cnt dot collect print of I and hit enter. You can see that there are 68,883 records. And if you want to run another query using SQL context, you can say self star from orders, limit 100, hit enter, and you can actually get the results. 100 records. I'm not sure why it says broken pipe. Okay, it seems there was some issue with my VM. Anyway, we are able to see the results. You can also say cnt.count and see whether it returns 100 or not. Yeah, there are some issues. So let me kill this and then start the Pyspark again. Once it launches, we will rerun whatever we ran so far. Okay. So this is how you can register the orders. It's a okay, how to import this? I have to start from here. It's a four-step process. First you have to read the data, then you have to split, and then you have to assign the schema, and then you have to infer the schema and then register the temp table for that. So two maps, one reading the data and then inferring the schema and temp table. So four step, two maps, reading the data, inferring the schema and registering the temp table. Okay, now let me copy this. I have to copy from here. Paste. The same thing is for order items. Only thing is this map statement have more columns. Here we have 0 to 5, 6 columns, and other than that everything else is same. And paste. And then we can run the same query which we have ran using HighContext to get the aggregated data. So if you are very familiar with Hive, the same functions might not work with the Spark SQL context which we are using now. For example, if you go to my code, I'm using round to actually get the subtotal with 2 decimals. If I try to use the same round function in Spark SQL context, not the Hive context, then it will throw error because round is not a valid function in the Spark SQL context, but it's a valid function in the Hive context. So that's the only difference between the previous query and this query. Now we have already ran the query. Now we are printing the output. Paste, and you can see the results in a moment. Now it has used only 10 because we already have that set Spark SQL shuffle partitions equal to 10. Otherwise it will launch 200 tasks on each and every hop of the DAG, which stands for acyclic graph. And also you can see the results. If you want to do order by, there are multiple ways. I am using sort by key. Probably it might not work here. Let's see. Yeah, it is not working here because if you look at the result set without sort by key, it is actually returning the row object. So you cannot sort using sort by key on row. Again, you have to map and then sort it. Or you can actually define order by in the query itself. Order date, and then copy paste this one and hit enter. Now you can see the data in sorted order on order date, and it should be 165 and 97,076, which is correct. So I have shown you how to write the scripts to join the datasets by using Python without any SQL in that, and also have shown how you can leverage HighContext to access data on the Hive tables, and also how you can actually define schemas by using SQL Context Inference Schema command and then write queries on top of that. Last two will be more elegant way of writing or processing the data on structured data set, and this approach will not work on word count, but this approach will work for all the structured data wherein you can define schema, and this will be the better way to join the data sets rather than struggling with plain vanilla Python. And if as part of the exam, if they don't specify that you have to write the script using Python, then I will highly recommend you to use SQL Context, either Hive or Spark SQL, to perform more complex operations using Spark. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to discuss on the certifications, I have a LinkedIn group called ITversity Hadoop certifications for the certifications. You can send the request to me and I will accept. Also you can send request to ITversity Apache Spark also if you want to discuss on Spark itself. And if you want to ask any technical questions, use Stack Overflow. You can it's better to sign up and then click on ask question. Once you ask the question, please tag with Apache Spark or Pyspark. I will closely monitor them and I will try to answer to best of my knowledge. Finally, if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.